Hi, welcome back to the series. Today we'll be doing chapter 4. So for chapter 4, we'll be splitting into two parts. Part 1, polynomials, and second part will be partial fractions. So for today, we'll be doing part 1, polynomials. Okay, so let's start. So polynomials, they're usually represented by letters like fx, qx, px, etc. And then the degree of polynomial depends on the highest power of x. So for example, if you have ax cubed plus bx plus cx plus d, the highest power will be 3, so the degree is 3. Then for x squared, the degree will be 2. Okay, now let's move on. So for division of polynomials, usually will be equals to the divisor times quotient plus remainder if there is. Okay, so now let's get on to the most important part of polynomials, the two theorems, factor theorem and remainder theorem. So for factor theorem, let's say that if ax plus b is a factor of fx, then f negative b over a will be equals to 0. Okay, so let's see an example. So example, if x minus 3 is a factor of x cubed plus x squared minus 11x minus 3, so we will make the factor equals to 0, then we bring over the number, then we will get 3 here. So we sub in 3 into the equation. So f3 equals to 3 cubed plus x squared minus 11x minus 3, which will give us 0 ultimately. So this means that remainder equals 0 as x minus 3 is a factor. So factors give us 0 remainder. Okay, now let's move on to remainder theorem. So when fx is divided by ax plus b, it will give us a remainder of f negative b over a. So let's see this question. So when it's divided by x minus 2, make it equals to 0, and we bring over, we get x equals 2. So f2 will equals to, start in the values into the equation, we get 56 as a remainder. Okay, so now let's try a question. So when the polynomial fx equals to 2x cubed plus ax squared minus 2x plus b is divided by x minus 2, it gives a remainder of negative 6. Given x minus 1 is a factor of the polynomial, find the values of a and b for this for part 1. Okay, so now we're doing the remainder theorem part side. So they say when it's divided by x minus 2, we make it equals to 0 and we get equals to 2. So f2 should be equal to negative 6. Then we sum in all the values, then we should get our first equation. Okay, so for the second part, when x minus 1 is a factor, then we make it equals to 0 and get x equals to 1. So f1 should equals to 0 by factor theorem. Then we sum in the values, we should get our second equation. So when there are two unknowns, we need two equations. Then we'll do our substitution method, and we'll ultimately get these two answers. Now let's do a second part. Hence factorize fx completely. So for the first method, we'll be doing the long division method. Long division method. So we simply take the whole polynomial and we divide it by the factor. Then we do our long division, we should get this. Then from this step to this step, we just press calculator, can already. Yeah, then we get an answer. Okay, so there's a second method to this. So this method is the comparison method. So we have our polynomial here, and then we'll break it up. So we'll get this. So for this, right, a and b are unknowns, but for this, we know that it will be 2 because it's 2x cubed, right? And what times x will give 2x cubed? It's the only possible one is 2x squared. So this 2x squared is already known. So we have the unknown ax plus b. Then we just open it up and then compare. After comparing, we'll get both our answers the same. Get to here, then we just here press calculator. Okay, so that's about it. So for this, right, actually the long division method is preferred because it's much easier, as you can tell lah. It's much faster. Okay, so that's it for this chapter.